Hello everyone. If you are also ready, then maybe we can slowly start. Can you open the slides? So, my name is Nina, and this is Alex. And today we're going to have a short 2-hour workshop about how to write Solidity smart contracts. Can we switch to the next? Just technical details. Okay, just a second, please. Hopefully, yes. So as I said already, Nina and Alex, but if you want to follow us or message us ever with some questions on Twitter, Gitter, Telegram, this is our names everywhere, practically on GitHub also. Our background a little bit, we joined the ecosystem approximately 3 years ago as contractors with the Ethereum Foundation. At the beginning, we joined to help build the editor for Solidity called Remix, if anybody already knows it. But because we are also teaching programming and Solidity in general, we figured out that we need more easy version of Solidity editor. So we started building another project called Play, which is a playful editor suitable for beginners, so later we will try it out. But other than that, in the last months, we are also building a smart peer-to-peer search engine for Solidity source code. So later, when you learn already about Solidity, you maybe want to search for some code examples. And on that search engine, in the future, now it's alpha, but you will be able to find some code snippets so that you can copy, paste, and combine when you start building your own contracts. And one more additional thing, for 2 years already, we have a community in Taipei called Wizard Amigos, and it's a meetup that is happening every 2 weeks, and it's focused on learners. So everybody who wants to learn programming, if you're a complete beginner, you can come and join this community, and Nora is, she's from Taipei, and she's organizing the events. So after this, you can also join this community and continue learning. So today's workshop, we will split into approximately 3 parts. So because we could immediately start with Solidity syntax, but maybe it's better to have like some general understanding how things on blockchain really work. So when we write a smart contract, how will this even fit into the whole ecosystem? So we will go through these kind of basic concepts so that we kind of go through the main, how do you call this, like a vocabulary. So what is, I don't know, Ethereum virtual machine, what is blockchain in general, so these kind of things. Then we will go through Solidity syntax, so basic examples and 2 more complex examples, and then we will try out this Solidity code into in the editor. So we will also interact with these contracts, because contracts then we can deploy them to the Ethereum, and then we can send transactions and retrieve transactions, and this is what we will do in the last part. So we want this to be like a relaxed thing, so if you have any questions in between, please ask, because it's useful that we know if somebody is stuck. We also have a chat. So what you will need for the workshop is the Play editor, MetaMask. We will later go through everything, so no worries. And the Gitter chat for questions. So Gitter chat, do we have it still? It's to Wizard Amigos. So this is the Gitter chat. So this is always, not just today, always if you have any questions, this is the chat where also Nora is and the Wizard Amigos here in Taipei, so you can always ask for some questions here. Okay, so I think this is an introduction, and now we can jump into the basic concepts. Is it okay, like English slower, everything good? Cool.
Okay. Alright, so basically, yeah, let's get started. So the basic thing that is maybe a big difference, and maybe most of you might know this already, maybe some don't. Like a main difference is like when you use Facebook or any traditional app, you sign up with an email and password, and that's not the case anymore here. So what you instead use is a wallet, and because we're today doing things in the browser, we're using a wallet that is called MetaMask. And what it does, it basically uses some math to generate two pieces of data. So there are like little programs that can generate you this. So this is like just an example of a form where the math that generates those two pieces of data is already baked in. And when you generate the key, it basically gives you here one private key and one public key. And basically how it works is you publish one of those pieces of data, which is the public key. It's just a combination of zeros and ones. You give that to everyone in the world, you publish it in the internet. And it's basically, in the Ethereum context, also your address, the way how people can talk to you, send you data, interact with you. Otherwise, on Facebook, you sign up with your account, email and password, and then people can talk to you using that Facebook account. But here, instead, you have these zeros and ones, which are your public key. Everybody knows it because you publish it, and that's your account. Now, the thing is, with that math that generates those two pieces of data, you can use the like a text, and you use your first piece of data, and you use a little algorithm, like basically like a little math formula, to convert that data together with that other piece of data into something nobody can read, and then you can use. Then everybody in the world can basically use the second piece of data that you made public on the internet to get back from that unreadable piece of text the real text. And because you are the only person that is supposed to have the private key, that means everybody who can successfully turn that gibberish into the real text knows that has to be created, that was created by you. Because you're the only one who can do this. And in the same way, somebody can use the public key and take some text and turn it into gibberish, and the only person that can turn it again into the clear text is again you with your private key. So you can receive messages. So that's kind of the basic principle that the wallets use to create an account in this new way or world of doing things. Right, so then what is Ethereum? So basically Ethereum is you are having a little software that you can run on a computer, and all the computers that run it, they join into one network, and that's the Ethereum network. And that's what we're going to program with Solidity. So basically, every of these nodes that build this giant network has inside a growing list of data, and they synchronize. Like all these nodes, they synchronize the same data. And that is what is the blockchain part. And each of those blocks, you have, it stores a list of transactions, and that is basically an interaction between so-called contract accounts and user accounts. So you created your user account with those keys. The public key is your address, and the blockchain will store in the blockchain, in every block, transactions that are interactions between contract accounts and your user accounts. So how does the blockchain link blocks? So there's another thing. We've just mentioned the public and private key. Now, if you have any text and you use a hashing algorithm, and it turns it into some small piece of data, and it's always the same length, no matter how big is the data that you put in, and it's for the same piece of data, it's always the same, like a fingerprint. You cannot create from the fingerprint the original piece of data, the same as from my fingerprint, you cannot create me, but if I'm around, I can always give the same fingerprint. So if you have like a text as input, you get like a hash. That's like a small piece of data. If you take a different text, you get a different piece of data. Now this sentence says the red fox runs across the ice, and this one says the red fox walks across the ice. It's a small difference, but the fingerprint is different. But if you take the same text twice, it gives you the same fingerprint. Now how's that used? Basically, in every block you have transactions, but you also have a hash to the previous block. So you take one block that has transactions, and it has a hash, and the next block will point to the previous hash. So that way you can prove if somebody sends you a previous block, you can use the hashing algorithm, like this one, and figure out what is the fingerprint of that block. And if you do that, you can compare it with the second block if it says that that's the previous block. And if that's the case, that's supposed to be cryptographically proven that this was the previous block. And so in every block, it adds another block with transactions. And again, the transactions are always between contract accounts and user accounts. And here's like a little bit higher resolution of how this all works. So this block here says it's a list of transactions, but also there's a state. So transactions is like for example, a very simple transaction would be I, from my user account, send some money to another account. And then the state changes and says, okay, we reduce my balance. Let's say I send 5 Ether or something smaller, and I increase the balance of the receiver. So every time we add a block with transactions, it also updates the state. Now let's do that in more detail. So here you see state, that's part of one block, and here's again state. So this part is now state, and here's another state. So here you can see the address of a user account. That user account has 1024 ETH. Here's another account, but that's a contract account. So it also has ETH, but it also has some code. And it has some data that is stored with that account. Here's another account, it's also a contract account. It has no ETH, but it also has some code. And here's another user account. Now somebody sent a transaction, and we had initially that state in the current block, and that's the transaction. In reality, there will be more than one transaction from one block to the next. But what that particular transaction says, it says this account, which is this one over here, talks to this account, which is a contract. It's this one. And it says value 10, so it sends 10 Ether from that account to this account. And if you see here, this account has 1024 Ether, and now it has 1014 Ether, because it sent 10 Ethers. But this other account had 5202 Ether, now it has 5212. So it received the Ether. So in the new block, the state is updated. Now what else is in the transaction? There's data, and it says data. There's two pieces of data, a number and a name. So this is a list. The first item is 2, the second item is Charlie, the name. Now here's the code. That code says, I'm not sure if you can read it. Maybe I can read. So if the contract storage, so contract storage is basically the data that is stored in the contract. This is this list here. And TX means transaction, and data 0. So that means the first item from data is the number 2. So contract storage 2. So you always start counting in lists from the 0. So this is item 0, this is item 1, this is item 2. So if there is no contract, nothing stored in the position number 2 and 0 is perceived as there is no value in this case, then contract storage, again, transaction data number 0, that's the number 2. So set this one to transaction data 1. So we take the second item from the transaction, which is the name Charlie, and we put it here, where the 0 is stored. So if you see on the other side, there's Charlie. So it updated the 0 with Charlie. So in order to get from the one block in the blockchain to the new block in the blockchain, the transaction was executed and a state transition happened. So the money was sent, that was the simple part, and the next part means actually the thing that is called the EVM, the Ethereum virtual machine, executes the code together with the transaction data in order to update the storage part in the next state. Now that happens for all the accounts and all the transactions that happen between one block and the next. All right. So, and that's what we're going to program. So basically, when we write contracts, we would create new contract accounts. And a contract account has an address, it can have a balance, like a private account, but the private account was, we're using a wallet, like I showed on the first slide, with a public and a private key, but that's usually controlled by a human, or it can also be a program. But the second type of account, the contract account, that's transparently on the blockchain. They don't have public and private keys, and they cannot do anything on their own. So only when a human or somebody who has a wallet or a public and private key starts a transaction, then maybe a contract account like this one, the human or the wallet that has this address started the transaction and talked to the contract. So the contract, the code will get executed according to the code that it stores in the contract. And that's what we will program. And it causes updates. Now this code can also talk to more contracts. And those contracts can talk to more contracts. So if somebody, a wallet, starts a transaction, it can touch more than one contract. But now this is a simple example. So here the contract only updates his own storage. He doesn't now also talk to more contracts. All right, that's on the next slide. Oh, right. So here again, the blockchain, it starts with the first block. You have some transactions to come to the next state in the next block, and so on. And here, that's basically the same graphic. So from one state, one transaction to the next one, and it always goes on like this. And the state is the part down here. And the red arrow is the hash, so each block is linked to the previous one with a cryptographic hash. And also attached is a list of transactions. So it's a little bit of a simplification, but generally this is how it works. So you have some metadata, you have the linking between blocks, you have the state, there's a code section which stores the code, there's a balance which is basically the same as the storage, but the storage means you can store any data, depends on the contract, while the balance is a special place to store the ether, because they have a separate meaning, or in this case a special meaning, that they have value. Now of course every time you execute a transaction you also have to pay for gas, because every update that you do needs to be executed by all the nodes in the network, and if there's a lot of nodes they all have to update the storage, and that's work for them. So the ether that you send, they're supposed to pay all these people to update the database. Now once the database is updated, if you run your own node, you have a local copy. So when you read from the network, you can read from your local copy, Because when somebody writes to the network, every node gets updated, which includes your own node. So then you can read the data from your own node, so nobody else in the network has to do any work, and that's why the reading is free. All right. Now let's try to put it all together. So we have user accounts. So we are using this wallet MetaMask because we are working in the browser, and it can generate public-private keys. The private keys is something that you keep secret. Maybe you can even write it down on paper and put it in a safe. The public key is your address on the network. This one is supposed to be a dApp. It's like an app, but it's a decentralized app because you don't sign up with a password and email address. Instead, you use your private and public key through your wallet, which, for example, can be MetaMask. And then you can click on the app, you can type text. It's just like any normal app. But the wallet uses your private key so when the app sends a message to the blockchain, to the Ethereum network, it signs that with your private key, so that the network knows, okay, that came from you, not from somebody else. Now, the app itself can be written in HTML, CSS, and JavaScript, for example, but you can also use a mobile app or any kind of app. And depending on the language, usually there is a Web3 JS library that basically helps you to make the app when people click buttons to talk to the Ethereum network. And the Ethereum network, here you see the list of blocks. That's basically the blockchain in one node. There's a copy on every node, which stores the storage and the list of transactions, and then comes the new block with the new storage and the new transactions, because there's always the state transition. Yeah, right, that's it. And in this network, you have smart contract accounts. So that's where the code is stored, like we saw earlier, and that replaces to some degree the traditional server. So instead of an app talking to the servers of Facebook or any server, a lot of this can be done by talking to smart contract accounts. And those smart contract accounts are addresses in the blockchain, and if you run on your node, you have a copy of that. So maybe, yeah, now we can basically do a little demo time. Do you want to do that?
Yeah, I know that this was now like a lot of information, but this, you don't have to know everything by heart. It's just to have a feeling of the space. What are we gonna do? So don't worry if you didn't understand everything. I also didn't completely follow in between. I got distracted. But we were thinking to start with installing a MetaMask. So does anybody already have MetaMask installed on your computer? Oh, a lot. Okay, so then maybe you can help your neighbor who maybe doesn't have it yet. So let's just kind of quickly go through how to install it. So, as Alex mentioned, MetaMask is our user account, and when we are using any kind of decentralized app, this is how we can sign transactions. So go to the metamask.io, and if you're on, you have to be, I think, on Firefox, Chrome, Brave. I don't know if any other browser supports MetaMask, and then Opera maybe also, yes. So click on Get Firefox add-on or Chrome, add it to your browser. Then we have to install it. The slides were also sent on the Telegram chat, so if somebody wants to go back, or you can open them yourself. So okay, confirm everything, and because you probably don't have a MetaMask account yet, just create a new wallet. But if you by any chance want to reuse the same one on another browser, you can also import your wallet. But for now, just create a new wallet. Can you just raise a hand who is installing now first time? Just that we know who maybe needs help. Okay.
有需要帮忙的可以举手一下，然后就会过去。
So we have really just 5 people installed. Yeah. Okay. So for those who have it already, okay. Because we will be trying out transactions, you probably already know these test networks that you can use, but some of them take like a long time. So we learned now that there is a new one called Ethereum, which is proof of authority. That's why it goes super fast. So I recommend you to add a custom RPC to your existing MetaMask. So just click on the extension and just click this custom RPC. So this would be very useful. So here, sorry. And you can just add here a custom RPC. Okay. And maybe I will just switch to the next one because we have to fill out some information about this custom RPC. If you have slides open, you can click here and get things that you can copy from. But otherwise you can also just write it manually. This will really speed up all the transactions on your remix or play editor. So first is Ethereum, then it's ABA. Does everybody see that? No? Then let me just send you the link to this on Telegram. Yeah, are you on the chat already? Maybe using this Wizard Amigos chat? Yeah. So can I send it here? It is already. And I can send also exactly the slides, but you cannot copy from this here. Oops, is it? Oops. I'm very sorry, I'm switching, so some people are trying to... Okay, now I keep it open, I'm very sorry. Does anybody need help? Alex can go around and help. Just raise a hand and we can... So just maybe if somebody cannot see, this is HTTPS AVA, so ava.network :201015/ext/evm/rpc. And here it's athexplorer.ava.network.
Can you send out the text? Send out the text to the chat.
Yeah, I think the best would be here, yeah, this one, yes. Here you can copy parts, you see? Yeah, the full text, bravo. I know this is a little bit annoying part, but I promise you will be super happy when you interact with contracts because it's fast.
我有录制了一段影片在那个 FB， 那如果说你要设置，可以看到，还有可能 video， 对，
Really? Now you made a video, wow. So we have a mini tutorial already made on the spot. Woohoo! That's nice. And also, like for those who already did it, just that you are not bored, you can click and create another account, because when we play with the smart contract, we need more accounts. So one time you will be Bob, one time you will be Alice, so you need like account 1, account 2, and then when you have it, you can also go to the faucet. This is a name for getting free tokens for this test network. So this is also a link that I can send you. And from here, what you need to do here, let me send the link. To the chat, I'm sorry, which is the first, okay, I have tons of chat. So here you have a link to the faucet. This one. And how do faucets usually work? So when you have your account, you can click on the account, and this will copy the address of the account. And then you put this address into the faucet, and you are actually asking the faucet to give you some free ethers. So you copy-paste your address, tell them that you are not a robot, or if you are, just lie. And then you can request some funds, and at the end of the whole game, you should have hopefully 2 accounts, and both accounts will have some ether. So I will also request with my account 1. Yay, success. So let's see. It takes some time, let's see if it did already. Ooh, maybe we all know the request, a lot of people. I will try again. Really, I just got it. Okay, so maybe because we are all now requesting from the faucet, it takes a little bit. And maybe if somebody is even done with all this, and you can even go further step, but it's not necessary, you can, for easier playing later, you can just name your accounts, like to Alice is 1, for example, but you can also leave it as account 1 and account 2. This is just like a sugar on top if you have time. So, I don't know why all the time it's Alice and Bob, but yeah. Okay, let's see. So, is anybody who still didn't manage to set up this custom RPC? Do you all have Ethereum now in your MetaMask? If somebody is still stuck on this step, please let us help you. And Nora can also maybe, she speaks Chinese. Very good. Somebody needs help? With these workshops, it's always like some people are super fast, some people are more slow, so I hope you can be patient. So the end result, you have Ethereum in your MetaMask, and you have hopefully 2 accounts, and both accounts have some test Ether. And if you feel Olympic, you even name them with some funky names, like Alice and Bob. Okay, I think majority is ready. Everybody ready? There is one little team that still is debating stuff, but I think they will figure it out. So, can we continue? Yes?
Okay. Okay, most of you probably had MetaMask already, but basically, if you created MetaMask now, you got your public and private key pair, and it also gave you the chance to back up your keys. Now for the test MetaMask account, it doesn't matter, but if you ever use it with real funds, you should better do that. Because there is no forget password button. If you lose the private key, then you can never get it back. So now the thing is that is left is like how to do the contract accounts. So you have the traditional contracts, that they work with lawyers and they're expensive, and you have smart contracts. They have code and they live on the blockchain. So again, this we saw earlier, you have transactions, and transactions are messages. So each transaction has a sender who sent the transaction and a signature. Means you use your private key to take the transaction data and sign it. So basically combining your private key piece of data with the transaction so that everybody on the network, because your public key is public, can see, oh, I can use this data that you sent to the network and figure out the real transaction data the way it's written here. And that's only possible if it was encrypted or signed with your private key. So that's how you prove that you are the sender. So then there's a receiver in the transaction. In this case, that's this contract address. But it can also be another wallet. So these are called external accounts. So this account here could, of course, also send ETH to this user account here. It doesn't have to be a contract. Now the thing is, it can also be empty. So you can make a transaction from your account to no account. So what that means is, if you do it, then the Ethereum network will think that the payload, so the payload is just another word for data, in a way. So this one, what we saw earlier, that's called the payload. Now, in this transaction, this was data that is meaningful in the context of this contract, because it has code. But if you don't have a receiver, so if the receiver is empty, there is no receiver, it's just a sender, then the Ethereum network expects that the payload will be code. So you basically are sending code to no address. And what that means is the Ethereum network will generate a new address, and the code that is stored in the data section will be the initial code for that new address. So what you're doing is you're creating a new contract account. You have a wallet, which is your user account, and you can send a transaction to the Ethereum network with no receiver and code in the transaction message. And that creates a new account, and it's a contract account. So basically, it looks like these accounts. It has a new address. It maybe looks more like this one, because it starts with 0 Ether, usually, unless you send it also Ether. And it has the code comes from, basically from the code that you send, but what the Ethereum network does, it executes the code. So you don't send the code that is the code for that account, but you send code which, when you execute it, will produce the code that you store. So that means there is an initial code that is executed only one time when you create the account, and it helps you to initialize the contract. So when you execute the code, it can already create a little bit of storage. Maybe you send code. Let's say you created a rental a contract, like a tenant agreement. You're the landlord and you want to rent an apartment. So maybe you wrote some code to rent out an apartment, and you send the code of the contract to the blockchain, but you also include the first tenants. And the first tenants are Alice, Bob, and Charlie. So it stores the code, which is the rental agreement, but it also already includes 3 renters. Maybe you have another apartment. You use the same code again to make another agreement, like to rent your apartment, but in that new contract you use different names, because it will be different people who will rent the apartment. All right. So
I'm sorry to make a little break. In 5 minutes, we will have a 10-minute break. There's some snacks just to prepare.
All right. So then, again, so sender is a transaction part, receiver, value, which is Ether, payload, which is data, and if you don't have a receiver address, the payload will be code to create a new contract account, and you also set gas limit and gas price. So when you send a transaction, all the computers in the network, they have to add that to their local database, and this process is called mining. It's a little bit more complicated, but in general you have to pay for that. And in order to not pay too much, you can set a gas limit and a gas price, and then it knows approximately, that only has to do with the details, which we don't go so much into today, but basically that has to do with paying for every transaction. Maybe just quickly, the way this works is there is a specification for the code, and every command or every statement, there's a list of so-called opcodes, and every opcode has a cost. And if you have a lot of code, you can break it down into lots of opcodes, and then you can basically calculate what will be the gas price. But sometimes you have in programming loops, so some code is executed multiple times. And the amount that this loop executes might depend on the data. So let's say you have a list of tenants. So if you have 3 tenants in your apartment, maybe the code has to run 3 times. But if you have a big apartment and you have 100 tenants, the code runs 100 times. And sometimes that makes it difficult to calculate the entire cost like perfectly accurate. So, but yeah, right. So so sometimes you can only estimate, but that's how it works. So the important parts is the sender, the receiver, and the value, and the payload, and then you have also some additional data. And then it creates a smart contract account. And the smart contract account has the contract address. It has the binary code, so it doesn't store actually the source code. So we will write a Solidity source code, but it will store that in zeros and ones. It makes it much smaller, so that it won't take so much space, because everybody who runs an Ethereum node has to store the code. It will have the value, which is, so when we learn Solidity, in Solidity, there's a special syntax to do something with the value, or to do something with the address, or to do something with the storage. So in order to know how to write Solidity code, it's good to know what is the environment. So there are wallets, and they have keys, and there are addresses, and there's storage, and there's all these things, and this is what we will program. So the storage is basically visualized here as this list. And as we saw earlier in one transaction, we replaced this 0 with Charlie, which means you update the storage. There's a memory, so the storage exists in each block. And every time you update it, the storage is still there. The memory is another kind of storage. While this transaction is executed, there will be something stored in the memory, but when the transaction was successfully executed, it will be forgotten. So if you don't want to forget it, you should store it in the storage while the transaction is executing. The stack is basically the place where the program stores all the commands that will be executed. So for example, this contract here, before it stores something, maybe it calls another contract. But when you execute and maybe checks if there's nothing stored, then it pauses, calls another contract, it does something, and then it comes back and it continues here in this next line. So that's basically the stack, helps you keep track of this. And then there's also an event log. So events cannot be, you cannot read the events inside of the contract, but you can create new events. So the reason is that when you send, let's say you transfer the contract sends some tokens or some kind of money to another account, then you want to create an event that goes into the event log, and what can be done with events is wallets or apps, they're called dApps. They can read from the blockchain all the events that happen in one contract. So it's a little bit like a mobile phone notification or a browser notification. The contract only creates them, but your phone or your browser gets a notification, and then basically you know, oh, something happened, or you can run an app that knows, okay, when I receive this kind of event, I should do something. And then of course you have the transaction history, and that's basically just the blockchain and all the blocks with all the transactions that happened in the past. So this contract maybe has a very long list of transactions, because maybe many accounts sent transactions in previous blocks. All right. So, yeah.
So let's make a break, coffee, some snacks, and then hopefully you still come back in 10 minutes or so.